Hey guys, Travis Gillespie here. Let's take a look at this example. For 1 month, Mr. Gray recorded the time at which his train arrived. He organized his results in a frequency table, and we have a frequency table below. So he's run an experiment, and he's already collected the data here. So we have the time listed, and the time, what it really is, it's the outcome. So let's just write that down real quick. The time is the outcome. So what's happened here? So he's recorded 3 different times at which this train arrives. So it looks like the train can arrive between 6:50 or 6:52. It can arrive between 6:53 or 6:56 or 6:57 and 7 o'clock. And then we have the frequency below those outcomes. It's how many times it's happened, the train, how many times it's arrived between this period, how many times it's arrived between this period, and how many times it's arrived between this third period. So let's look at this first example. It asks to find the experimental probability. I'm going to highlight those 2 words, experimental probability, of a train arriving between 6:57 and 7 o'clock. Let's actually highlight these values as well. And I want to highlight that word between, but I'm going to use a different color so that it stands out a little bit more. Okay, between. So I'm looking at these 3 time periods, and I'm going to actually highlight this last one because this is the only time period that deals with times between 6:57 and 7 o'clock. And if I look at the frequency below, I can see that the train has arrived in this time period 5 times. So Mr. Gray's recorded it 5 times arriving between 6:57 and 7 o'clock. So let's go ahead and write this out as experimental probability. I want to make a note here that when you're writing out experimental probability, we always write experimental probability out as a fraction. So let's just actually make a note here that I'm just going to put a little bit of an arrow for experimental probability. We express it or write it as a fraction. And there's a reason for this. We are going to set probability up as a fraction, kind of like looking at it as the part over the whole, but we're going to use some new words. So capital P for probability is equal to, so the textbook will tell you it's equal to the number of times an event occurs over the total number of trials. But I have a different way of writing it. So if you want the textbook version, go online or look in the textbook and you'll get that version. But my version, I'm going to write it a little bit differently. So in fact, what I want to do before even writing that equal sign is I'm going to make a new note. The probability, I'm going to make a note here, of an event occurring. So of something happening, of an event occurring. And I'll close my parentheses now. So the probability of this happening, it's equal to, well, I said the textbook is the number of times the event occurs over the total number of trials. But the way I write it out, so here's my blank fraction right now, is the number of favorable outcomes on top. Over the number of possible or the number of total outcomes. Okay, so this is how I set up my fraction, and it works for me. If it doesn't work for you and you like the textbook version, use it. So now let's just put values in this fraction. So I'm just going to rewrite this as the probability, in this case, of the time being between 6:57 and 7 o'clock, that is equal to, let's go ahead and put my fraction bar down. Well, let's look at the number of favorable outcomes. In this case, the outcomes we're looking for are the outcomes that are between 6:57 and 7 o'clock. So that frequency happens 5 times. So I'm going to put 5 up top. The number of favorable outcomes is 5. Now what number goes on the bottom? It's the number of all possible outcomes, or the number of total outcomes. So here I've got to add up all of the possible outcomes that occurred. Well, I have 7 recordings here, 8 recordings here, and that 5 that was already placed down below. I've got to add all of these arrivals up. So 7 plus 8 is 15, plus 5 is 20. So I have 20 on bottom. Now I can simplify this fraction. So let's just create an arrow, and I'm going to change colors real quick. I know that 5 goes into 20 and to 5, so if I divide the bottom by 5, if I do it to the bottom, I've got to do it to the top. So now I have 20 divided by 5 gives me a value of 4. 5 divided by 5 gives me a value of 1. And we can box this up. Let's go on to the next problem. We want to find the experimental probability of the train arriving before 6:57. I'm going to highlight that keyword. Before this time is the keyword, and I want it to stand out. We're looking at any time that's before 6:57. So on my collected data chart here, 6:57 is in this last time period. So any time that is from 6:57 to 7 o'clock, I won't use. Let's get rid of those highlights now. And that means I must use times that are before this time slot or time period. So those time periods are 6:53 to 6:56 and 6:50 to 6:52. So to set up my fraction, again, the probability of this event occurring, the probability of being before 6:57, I've got to set it up as the number of favorable outcomes to the number of possible outcomes. So P is equal to, well, the number of favorable outcomes. This time it's 7 plus 8. So there are 15 favorable outcomes. The train has arrived 15 times before 6:57. Or another way of thinking about it, the train has arrived before 6:57 at least 15 times. So I'm going to write this number, or this value, over the number of possible outcomes, which we've already written before as 20. So I have 20 on bottom as the total possible outcomes. Now this fraction can be simplified. So I see that 5 goes into both of these values. If I divide the bottom by 5, I've got to do it to the top. Or vice versa, if I did it to the top, I'd have to do it to the bottom. So 15 divided by 5 gives me a value of 3. 20 divided by 5 gives me a value of 4. Cool stuff, guys. I'll see you in another video.